Good afternoon. Thank you, Payal, for having me in this show. And uh, other esteemed panels like TP Singh and Harish has talked about uh, different components of digital grid modernization. First thing is, why do we need that? So I'll try to give the perspective of utilities because I have been working for utilities for a long time. And what do they think about these digital new technologies? How do they want to adopt it? And primarily how the all this technology will be put into practice. So this is the perspective of utilities. I mean, all the nice things Mr. TP Singh has talked about thermal imaging. We have been using thermal imaging for uh, identification or basically the components of assets that may go wrong, maybe because of overload or by any other reasons. So now I've been basically asked to discuss more on FLISR. FLISR primarily helps in part location isolation and service restoration. So all the purpose of substations, lines, and other components of grid is primarily to supply a reliable power. Reliability of power is essential for the better economics of a country or state. I mean, better livelihood of the people, residents, and industrial production. The reliability, undeniably, is to be ensured by utilities. What are the components that can help better reliability? Before that, I would like to say that what are the parameters? SAIFI, SAIDI, CADI, CAFI are the parameters that basically help us to benchmark the supply reliability and and basically uh, help us to identify what is to be done, why something is happening. So that way, FLISR, uh, although in India it is at a very few places that we could, in private discoms, could deploy this technology, but I mean, in future, this will be the backbone of supply reliability, grid resiliency, and all. Primarily, how to locate faults, how to isolate faults, and in turn, restore service. This is the primary objective. All the digitalization, digital grid, digital twins, and all those things. I mean, you have to have the better supply reliability. Faults occur undeniably. I mean, you can't stop. You can minimize only, but ultimately you can't eliminate the faults only. It may be because of vegetation, because of the failure of electrical components, or manual or automation errors. All these things lead to the faults. And as per the voltage level, the intensity of the fault increases. And it's less on the LT voltage, it's more on the high voltage. In India, we have primarily the consumers on 11 kV or LT. In other countries, we have, um, I mean, we have better distribution system on the higher side, higher voltages like 132 kV or 66 kV. But predominantly in India, we have more distribution on 33, very less, but 11 kV and LT are predominant. So, uh, so, uh, fault location, finding out where the fault is. So the basic requirement of these things, you must have a proper mapping of uh, the assets. Uh, we have GIS mapping, and then we can know what assets are where. And if in case of there are faults, so we have the location of the fault. Now, second thing that we should know with the help of sensors in the field, what why the fault has occurred or what is the fault primarily. It is because of the component failure, it is because of the errors, or it is sometimes the faults are misleading. So all those things has to be analyzed. And then parts come the service restoration. Then we have to build the logic uh, as per the load flow, power flow, how the service can be restored. So there we need, there we may need auto reclosers or sectionalizers and other similar components. Primarily, we must have the logic. Uh, how the components, how the these auto reclosers or sectionalizers will be operated, so that only the faulty section is out of service and rest of the things are in service. Simultaneously, what is equally important is the communication. What type of communication we have? Either we are dependent on GSM, or we have utilities do have their own kind of systems. In high voltage systems, we have own PLCC kind of system, but in distribution we don't have PLCC, so we normally depend on the communication provided by the either telecommunication service provider or some other means, which are not, very, as of now, since very few implementations are there, largely, in my knowledge, people depend on the kind of telecom service providers. So this way, these are the important components. How does it operate? Normally, we have SCADA systems that has inbuilt logic for all this thing. Sometime for we have this plugged into the outage management systems, or we may have some other arrangement. But SCADA is predominant, where we have FLISR kind of arrangement. In all systems, basically, the SCADA systems are costly, difficult to maintain. Generally, distribution systems in large cities, important cities, we have SCADA system, and in India, still we are moving, though very at slow pace, but at some places we have a SCADA system. What I would like to draw the attention that we can have basically gap arrangements till we have full-fledged SCADA systems. FPI, fault passage indicators, are basic equipments that can help to locate the faults in approximate manner, not in very exact manner, but we can have idea. And particularly these are useful where our distribution system is large, long lines, and we have to travel, our linemen have to travel to manually identify the faults. There they can help. So initially, what my submission to this webinar is that at least FPI can be adopted at some places with the outage management system, if not that very sophisticated SCADA systems, and build some logic. We can have different protocols. Either it could be MQTT or any other protocol that can help better reliable service of these FPIs. One problem with normal FPIs is that they aggregate signals at the pole level and then they transmit back to the system. There is some issue because you have to keep that DCU, data concentrator unit, that captures signal from the individual FPIs at the wire level and transmit back to the system, central system. These need to be powered up always. So that is a big problem in the field with the FPIs. What we have observed that if FPI itself on the wire are fitted with SIMs and GSM communication module, then this dependency goes, and these communication module can be powered up by the FPI itself. So we can start with, in Indian context, with the FPIs alongside the outage management system, so that a sort of a small FLISR kind of arrangement is available and adoption starts. Eventually, that will grow into the more complex and better systems that would help. But my view is at least we should start at this place. Thank you.